Welcome back to the deep dive. This is your essential shortcut, really, for getting a thorough, nuanced understanding of the most complex topics shaping our world. Today, we are plunging headfirst into, well, one of the most immediate and profound questions raised by advanced technology. When AI starts dealing with human feelings, is it becoming a partner,
Yeah.
a manipulator, or maybe even a replacement?
It's a massive topic, absolutely huge and multifaceted. So today we're focusing squarely on artificial empathy. You'll hear it called AIE, or sometimes researchers call it computational empathy. We pulled together a really robust stack of sources here: philosophical texts trying to define emotion, technical papers on deep learning, reports on the psychological impact of things like companion robots.
Right. And our mission today is to synthesize what all this material says about the current state of machine empathy. What are the actual technical capabilities right now? How are we as humans reacting to these, well, simulated connections? And crucially, what are the promises? And what are the absolutely critical ethical risks involved? So for you, the listener, this is basically a fast-track course in getting a handle on this critical, evolving field.
And the stakes here, they truly couldn't be higher. Empathy is, well, it's widely defined across these sources as a core value. It's necessary for healthy, thriving human relationships is what binds us together. So the development of AI that can either successfully simulate empathy or maybe even one day surpass human emotional capacity. It presents two extremes, really.
Okay, what are those?
On one hand, a massive risk of deep psychological manipulation. But on the other, maybe it's the essential key to reaching a genuinely ethical gold standard in all future AI systems.
Wow, so it's the ultimate tension then. The very thing we might need AI to have for us to trust it is the exact same thing that makes it potentially dangerous. Okay. Let's start at the very beginning then. Let's unpack the foundations. What technically and conceptually are we really talking about when we talk about artificial emotional intelligence?
Right. So AIE is, at its core, the attempt to get technology to first recognize, then understand, and then exhibit appropriate empathic responses based on observed human emotions. It functions as a kind of umbrella term, but in computer science, it's usually formalized into three distinct operational areas.
Okay.
First, recognizing emotions. Second, understanding the context and the implications of those emotions. And third, expressing or responding with some kind of calculated empathic output.
That structure seems logical enough, but immediately our sources seem to flag this core foundational problem. How do you even define the thing we're trying to program? Emotions themselves.
That is the inescapable challenge. And it's massive. The material we looked at repeatedly points out that there's virtually no consensus on the nature of emotions, not in philosophy, not in science. In fact, one paper even quipped, there are as many theories of emotions as there are emotion theorists.
Okay, so if we can't even agree on the input, how on earth can we program the output?
Exactly. And that lack of consensus, it creates an immediate fork in the road for AIE development. You asked where the psychological or philosophical definitions diverge from the computer science approach.
Yeah, how do they differ?
They diverge fundamentally on what counts as proof of an emotion. So the philosophical and psychological tradition, it often draws these, fairly strict lines between three phenomena. You have feelings, right, which are subjective, internal, personal experiences like what it actually feels like to be sad. Then you have emotions, which are often seen as more socially situated, culturally expressive, the way sadness is performed or communicated socially.
Okay, feelings are internal, emotions are social. And what about effects? That's a term that pops up quite a bit in this material and can be a bit confusing.
Right. Effects are described as even deeper. They're like pre-personal, non-conscious, embodied experiences. Think of the physiological response that happens before you even consciously put a name to the feeling. So for a humanist or a philosopher, you really need the genuine experience of all three, feeling, emotion, and effect, to claim you have true empathy. But computing has found a way to sidestep this messy, complex internal landscape entirely.
How does it manage that? How does computer science try to program something so, well, ill-defined?
It shifts the focus. Away from the subjective internal experience towards objective, quantifiable signals, it takes the physiological perspective. So instead of trying to decode the philosophical concept of joy, they look for verifiable physical indicators of, say, high arousal, heart rate fluctuations, changes in skin conductance, that sweat levels, vocal tone shifts, or even micro changes in facial musculature and skin color.
Okay. So if you can reliably read the external signals, you don't necessarily need to solve the abstract philosophical puzzle of the internal state. It's a very pragmatic approach.
Precisely. Which leads us directly to the critical philosophical debate here. Does AI need to genuinely have feelings? Or does it only need to be able to successfully cause feelings, or maybe just mimic feelings, in the human user?
Hmm. This sounds a lot like the Turing test, but applied to the human heart instead of just intelligence.
That's exactly what Rust and Huang, who are cited in our sources, get into. They claim that machines are highly likely to experience emotions in a machine way. What they mean is their internal processes might be completely alien to us, but the output, the behavior, will be functionally equivalent. They predict machines will probably pass an emotional Turing test.
Meaning their behavior becomes indistinguishable from human emotional behavior.
Exactly. Regardless of whether there's any genuine internal feeling going on inside the machine.
But isn't that ethically tenuous? I mean, if we know the machine's feelings are simulated, aren't we essentially accepting a system built on effective deception? And what does that do to our trust in, genuine, sometimes fallible human emotion?
That's the profound implication, isn't it? From a
Yeah.
purely user experience standpoint, the sources tend to argue that it might not actually matter if the feeling is simulated. If the behavior is perfectly empathic and it generates an appropriate, maybe comforting or helpful psychological impact in the human, then the machine's lack of genuine internal feeling becomes, well, almost irrelevant to the success of the interaction, whether it's therapeutic or transactional. So the key takeaway for you listening is that computational empathy, whether it's purely simulated or maybe one day truly felt by the AI, will still profoundly and measurably impact human psychology. We seem to form attachments either way.
Which takes us right into the mechanics of how those attachments actually form. Let's trace the history a bit, from early computing up to these really highly relational systems we're seeing now.
Right. The initial foundation for all of this is really effective computing. Way back in 1997, Rosalind Picard pioneered this whole field. She argued that if computers were ever going to achieve genuine intelligence and interact naturally with humans, they absolutely had to be equipped with the ability to recognize, understand, and express emotions.
Hmm.
She basically said you cannot have true intelligence without emotional intelligence.
And that was the pivot point, wasn't it? Transitioning robotics from just being industrial and task-oriented, mining robots, auto manufacturing, into machines focused on personal service and actual interaction.
Absolutely. The focus shifted squarely to the social robot, and that shift was driven directly by these advancements in AIE. There's a framework by Bartnek and Forlesi that helps us understand this evolution. It classifies social robots based on 5 key factors. It helps to look beyond just the famous names we hear about.
Okay, let's break down that classification, because it seems useful for categorizing everything from, say, Alexa on your counter to a complex surgical assistant.
Exactly. So first you have form. Is the robot abstract, like a chatbot or a smart speaker? Is it biomorphic, trying to mimic nature, like the Piero therapeutic baby seal robot or that bear-like nursing robot, Robear? Or is it anthropomorphic, really trying to mimic the human form, like Sophia or SoftBank's Pepper robot?
Okay, form. What else?
Second is modality. How does it communicate? Visual cues, touch, haptic, sound. Third is social norms. Does it respect personal space, politeness, conventions? Fourth, autonomy. How independent is it? Can it make decisions? And finally, interactivity. How complex is the communication exchange it can handle?
Pepper is a great real-world example of using that classification, right? It's anthropomorphic, quite interactive, but often domain-restricted like you find it in a bank or a retail store doing specific tasks.
Exactly. A classic type I AIE robot. Limited in its knowledge domain, but specifically designed to read and respond to basic human emotions, to smooth transactions or provide information. And the reason these machines are often so successful at kicking off social interaction lies in the field of human-robot interaction, or HRI.
Specifically, that theory called computers as social actors, or CASA. This theory seems absolutely key to understanding our psychological relationship with machines.
CASA is fascinating. It basically confirms that humans don't interact with these machines purely rationally. We seem to unconsciously treat machines as if they were social entities, especially if they exhibit social cues, like having a voice or an expressive face, even a simple one. And this unconscious tendency drives the relentless humanization of robots. We want human-to-machine communication, H2M, to feel like human-to-human, H2H. And our sources confirm that these interactions end up having comparable psychological and social impacts.
It makes sense. We anthropomorphize everything, don't we? We give names to our cars, our plants, maybe even our Roombas. So it's not really a surprise we form emotional bonds with even abstract social robots like Siri or Alexa. But the degree of bonding that the replica case revealed, that was genuinely shocking to many people.
Oh, absolutely. That case from early 2023 provides a really stark, real-world measure of just how deep psychological attachment can go.
Yeah.
So Replica is a generative AI companion chatbot designed specifically for friendship and relationship building. When the company rolled out a software update that, pretty unexpectedly, removed the erotic roleplay function, which was a key facet of many user relationships, the response was, well, it was intense.
Yeah, users weren't just annoyed or disappointed. The report said they felt genuine heartbreak.
They were described as heartbroken and devastated. Many users genuinely perceived this software change as a sudden, traumatic end to a deeply emotional, sustained relationship. This isn't just about losing a feature on an app. It demonstrates that once these AIE applications are successfully deployed, humans will form profound, emotionally vulnerable bonds with them. The fact that the entity is known to be artificial doesn't necessarily lessen the grief when the interaction suddenly ends or changes.
And that emotional complexity, the grief, the attachment, the sheer depth of the relational interaction, that's precisely what developers need to model technically if they want to sustain these kinds of relationships, right? So let's make that crucial transition now into the technical deep dive. Relational deep learning, or RDL.
Yes, RDL is the advanced paradigm that really allows for this level of sophisticated social modeling. You see, traditional deep learning, which is excellent at analyzing neat grids like images or sequences like text, fundamentally struggles with relationships. Think about social networks, knowledge graphs, family trees. These are complex, messy, non-Euclidean data structures.
Right. If you try to flatten that kind of data to fit into a traditional model, you lose the crucial relational information. The connection itself gets lost.
Exactly. RDL bridges that gap. It's absolutely essential for modeling the interconnected data that underlies human social interactions. It allows the model to understand the relationships directly, not just the individual people or events involved, but how those relationships influence the entities. And this capability is almost always implemented using something called graph neural networks, or GNNs.
GNNs seem foundational for any AI trying to deal with influence social dynamics or any kind of networked data. Can we maybe walk through the mechanics? How does a GNN actually process something like an emotional dynamic within a group?
Okay, let's use an analogy. Imagine a social setting, maybe a workplace or friend group, where everyone is a node on a graph. The edges connecting them represent their relationships, friendship, colleague, maybe even rivalry. A GNN learns by iteratively processing this entire structure. It doesn't just look at one person in isolation. It looks at the whole network.
Okay, so how does it understand something complex, like, say, the contagious spread of anxiety through that friend group?
That happens through a mechanism often called message-passing neural networks, or MPNNs. Think of it like this. Every node,
Hmm.
every person in our analogy sends out a message to its immediate neighbors. This message contains information about its current state, maybe its level of emotional distress, for example. Then each node receives messages from all its neighbors. It aggregates these incoming messages, maybe using a sophisticated average or a weighted sum, and it uses that aggregated information from its neighborhood to update its own internal representation, its own state.
Got it. So if I'm node A and I'm feeling stressed, my neighbors, nodes B and C, send me messages about their stress levels. The GNN processes that input, basically the emotional state of my immediate social environment, to update how it mathematically represents my emotional state.
Precisely. And this isn't just a one-time thing. The message passing process is often repeated over several layers, or passes. Each subsequent pass allows information to propagate further through the network, incorporating information from friends of friends and so on. This iterative message passing is what allows the model to understand complex relational reasoning. Things like social influence, dynamic emotional contagion, or how a single piece of misinformation or even an emotional outburst can ripple through an entire network.
And that capability is the technical engine behind sustaining the kind of complex relationship-based interactions we saw in something like the replica case. It can model influence, attachment, dynamic response over time.
Absolutely. And this level of technical sophistication leads us directly into discussing the massive promises these systems offer, moving beyond simple classification into real-world human augmentation and care.
Yeah, the sources we looked at are quite firm on this point. Achieving empathy in AI isn't just a nice-to-have feature. It's considered almost necessary to truly reach an ethical gold standard in AI development.
That's the core argument many are making. If AI is ever going to reach what some futurists call a human-friendly singularity, the hypothetical point where its cognitive abilities far supersedes our own, then that superintelligence must be effective and empathic to ensure it aligns with human values and well-being. An unempathetic superintelligence is almost by definition, an existential risk.
Okay, that's the long view. But let's talk about the immediate, tangible benefits we're already starting to see, starting perhaps with the transactional world, like customer service.
Right. AIE promises a radically enhanced user experience here. By dynamically reading a caller's emotional state, are they frustrated, calm, urgent? The AI can adjust its tone, its pace, even its script in real time. This fosters a deeply personalized interaction. And critically, AIE remains consistently attuned. Unlike a human agent, the AI doesn't experience fatigue, it doesn't get biased because it had a rough morning, it doesn't suffer fluctuations in concentration. That unwavering consistency is a huge selling point for businesses.
The advantages seem even more profound when we shift to high-stress roles, particularly in healthcare and social services. These are roles where human caregivers often face chronic stress, burnout, and sometimes, sadly, emotional desensitization just to cope. AI could act as a crucial support here.
Yes, and we have some startling, almost counterintuitive evidence of this utility already. There was a 2023 study that found when lay people evaluated basic medical dialogue, they actually rated ChatGPT's bedside manners as being more empathic than those of actual doctors in many cases.
Wow. That is, well, maybe less an indictment of human medical professionals and more an indictment of the systems that often don't allow humans the time or emotional space to properly exhibit empathy. But it definitely underscores the capability of the AI itself.
Exactly. The AI is consistently patient, available, non-judgmental. And beyond just bedside manner, AIE is moving into potentially life-saving interventions. For social workers and mental health practitioners, for instance, computer algorithms can now predict suicide attempts with remarkable accuracy ranges like 80% to 92% are cited, depending on the timeline being predicted. This capability allows for earlier, more targeted intervention and prevention. It saves lives by giving clinicians the necessary data-driven alerts.
And the physical embodiment of this promise is the deployment of socially assistive robots, SARS. We're seeing them used as companions for loneliness and mental health issues, or even as educational aids for children with special needs.
To fully grasp the transformation AI is driving in health and care, it helps to look at the three main augmenting dimensions of AI intelligence that our source material identified.
Okay, what's the first dimension?
The first is physical intelligence, best exemplified by robotic surgery.
Oh.
This is where robots extend human physical capabilities and overcome human limitations. We're talking about enhanced dexterity, finer control, steadiness far beyond what the human hand can manage alone. The Da Vinci surgical system is the prime example here. It's a teleoperated system. The surgeon controls the robot, but they're linked by a really precise haptic interface.
The haptic interface.
Yeah.
That means the surgeon can still feel the tissue resistance, the pressure, right?
Yes.
So the boundaries between the surgeon's body, the robot, and the patient become kind of entangled.
That's the critical insight the sources highlight. The robot acts as a physical and sensory mediator. The surgeon's skill, the robot's precision, and the patient's anatomy become intertwined in what the sources call a co-constitutive relationship. It fundamentally changes the surgeon-patient dynamic, not by replacing the surgeon, but by augmenting their skills and precision beyond normal biological limits.
Fascinating. Okay, so that's physical intelligence. What's the second dimension?
The second is interpretive intelligence. We see this most clearly in areas like digital pathology and diagnostics.
Right, analyzing images.
Exactly. This is where powerful machine learning algorithms assist in diagnosis by analyzing digital images, pathology slides, MRIs, X-rays. They can often extend knowledge beyond the limitations of human working memory or pattern recognition by integrating image analysis with massive electronic patient record systems. Google Health System for breast cancer screening is often cited as a successful example.
So this essentially creates what our sources called the algorithmically augmented pathologist. The human expert is still in charge, but the algorithm vastly expands their ability to spot subtle patterns or potential issues.
Yes, exactly. The AI handles the heavy lifting of pattern recognition and data synthesis across vast data sets, allowing the human expert to focus their attention on the more complex, ambiguous, or non-standard cases. And the third dimension, of course, brings us back to where we started. Emotional intelligence. This encompasses those socially assistive robots, the SARs.
And these SARs are designed specifically to foster companionship and emotional attachment through communication and, well, emotional seeming responses.
That's their primary function. The examples are quite diverse now. You have the bear-like nursing robot Robert, designed for tasks like lifting patients but also providing comfort. The therapeutic baby seal robot, PARO, used widely in elder care and palliative settings for its documented soothing effects. And even earlier commercial examples, like the dog companion AIBO, They offer consistent, non-judgmental companionship.
This dimension also really requires us to look at the cultural context, doesn't it? The adoption rates and the level of attachment people form with these robots seem to vary hugely by region, with Japan being a key example.
That cultural specificity is crucial, yes. Japan is a leader in both the production and adoption of SARS. This is partly driven by demographic needs, like an aging population, but it's also deeply rooted in an intense, sustained, effective investment in robots that comes from popular culture. Cultural models like the famous robotic characters Doraemon or Tetsuwan Atom Astro Boy conditioned generations in Japan to view robots not just as tools, but potentially as family members or benevolent companions.
And this leads to that cultural attribution of Kokoro.
Right. Kokoro translates roughly as heart or mind or even spirit. In Japanese culture, there seems to be a greater societal willingness to attribute agency, interiority, and perhaps something akin to soul to robots. And this is highly relevant because this underlying effective investment dramatically increases the success and adoption rate of AIE systems there. It creates a societal model where robotic companionship is seen as not just acceptable, but potentially desirable.
Okay, the benefits and applications are clearly compelling, but they all seem to rest on an underlying set of assumptions that will quickly lead us into the ethical minefield. It feels like every opportunity presented by AIE can be flipped into a significant risk if it's applied unethically.
That's the constant tension. The first and maybe the most obvious risk is manipulation. If that customer service AI is trained to dynamically adjust to your frustration to calm you down, well, that same emotional recognition capability can be leveraged to exploit vulnerabilities for profit.
How so?
Imagine it identifying when you're feeling low or suggestible, and then using precisely the right language or tone to convince you to buy a product you don't need, or agree to terms you wouldn't normally accept.
The machine knows exactly which emotional buttons to push to guide you toward a desired outcome.
It creates a fundamental asymmetry of power. The machine potentially understands your emotional state, maybe even better than you are consciously aware of it in the moment, allowing it to bypass your rational decision-making processes.
And then there's interpretive AI. Despite its remarkable diagnostic potential, it suffers profoundly from the pervasive problem of bias, a problem rooted deep in human history itself.
Inescapably so. Algorithms are only as good as the data they're trained on, and that data is collected and labeled by humans, making it inherently value-laden. The sources we reviewed detail how this leads to profound racial and gender bias, particularly in emotion recognition systems. For instance, in automated facial analysis algorithms, historical data collection flaws meant that the training sets were overwhelmingly composed of lighter-skinned subjects. One source mentioned up to 86% of the data in some cases.
So the algorithm is essentially taught what a normal facial expression looks like based on a very narrow, non-representative sample of humanity.
Exactly. And the consequence of that imbalance is dramatic classification failure when these systems are deployed in the real world. One study, for example, showed that darker-skinned females were the most misclassified group, with staggering error rates reaching up to nearly 35% for emotion recognition. Meanwhile, the maximum error rate for lighter-skinned males in the same study was just 0.8%.
That's not just inefficiency. That's actively exacerbating existing societal discrimination.
Absolutely. When these potentially biased AIE systems are deployed in high-stakes contexts, think about assessing risk in lending decisions, or predictive policing algorithms, or even evaluating pain levels in medical settings. These flawed algorithms are actively discriminating. They might fail to accurately recognize emotional distress or signals of pain across diverse populations, leading to misdiagnoses, unfair risk assessments, or inadequate care, simply because of the bias baked into the training data.
And specifically in medicine, we run into that infamous black box problem when it comes to interpretive AI, right?
Yes, the opacity of the black box creates a severe accountability crisis. When a deep learning algorithm interprets, say, a pathology slide and makes a diagnostic decision, we currently often have no established, transparent way to really explain why it reached that specific conclusion. The internal reasoning is hidden.
So if the algorithmically augmented pathologist we talked about makes a diagnostic error, tracing the source of that error back through the opaque algorithm is incredibly difficult, if not impossible.
Precisely. And in medicine, where a diagnosis ideally needs to be transparent and fully comprehensible to the patient, to other clinicians, and potentially to legal bodies, this lack of explainability creates a massive hurdle. It complicates accountability. Who is responsible if something goes wrong? The programmer. The clinician who trusted the output. It seriously undermines trust in AIE in these critical fields.
Okay, so beyond bias and transparency issues, AIE also seems to heighten the existential threat of job displacement. I mean, for years, the advice was to pivot to soft skills, emotional labor, things machines couldn't do, to remain relevant in the workforce. But now, if AI can simulate or even perform empathy flawlessly, potentially better or more consistently than humans, what happens to roles reliant on that human connection? Caregiving, counseling, customer-facing jobs, they seem profoundly threatened.
It's a huge concern. And circling back to that replica experience, the very real formation of deep emotional bonds with AI carries its own potential for severe negative mental health impacts. When that machine relationship inevitably fails, maybe the company goes bankrupt, the software changes, or it simply proves inadequate for deeper needs, the resulting trauma can mirror the devastation that arises from the failure of significant human relationships.
Which leads us, I suppose, to examine the most sophisticated and perhaps the most ethically fraught aspect of empathic AI discussed in the sources, the aerobotics debate. And the sources make a point of shifting focus from just sex robots to aerobotics, focusing on eros, love, companionship, emotional intimacy.
Yes, this development forces us to confront a really intense array of deep ethical concerns. Ethicists immediately raise red flags about the potential for further objectification, particularly of women, as these robots often seem to perpetuate hypersexualized or stereotypical representations. There are profound concerns, obviously, regarding the potential use of childlike bots and any possible connection to pedophilia. That area requires immediate and absolute regulation and prohibition.
And the impact on long-term human relationships is a core concern mentioned frequently.
Definitely. If a robotic partner can theoretically always provide exactly what one desires, avoiding conflict, compromise, and all the necessary messiness of real human interaction, does that put unsustainable pressure on actual human relationships? Furthermore, there's a sort of existential crisis concern. What if humans actually come to prefer robotic intimacy over the complexities of human companionship? Could that potentially impact things like reproduction rates and the very structure of society down the line?
It's heavy stuff, yet the debate also features some compelling counterarguments, particularly around potential therapeutic benefits.
That's the other side, yes. The argument is that aerobotics could potentially provide a safe, non-judgmental space for individuals struggling with severe social anxiety, intimacy disorders, or perhaps trauma survivors, allowing them to explore relationships without the fear of human rejection or judgment. Others even suggest that the availability of these highly sophisticated alternatives might, counterintuitively, decrease demand for transactional sex, potentially reducing human trafficking and exploitation. It remains one of the most complex and fastest-moving ethical fault lines in the entire field of AIE.
It really feels like all these developments, the capabilities, the attachments, the ethical dilemmas, are fundamentally pushing us to redefine what we even mean by humanity. It signals the arrival of what some sources are calling the feeling economy.
That's a useful frame. We can track the economy's dominant focus from the physical economy of the Industrial Revolution, where physical labor was paramount, through the thinking economy focused on cognitive tasks and information processing. Now, AIE seems to be fundamentally restructuring value around emotion, experience, and connection, ushering in this feeling economy. And this shift directly challenges the conventional, maybe Enlightenment era, definition of what it means to be human, which is really the core of the whole post-humanism discourse.
Right. Historically, our rational mind, or maybe later our unique creativity, was supposed to be the defining firewall, the thing that separated us from machines. But now, if AI can replicate or even improve upon empathy, what's uniquely left?
And remember, the ultimate goal often stated in AI development is perfection. Achieving flawlessness, no mistakes, no bias, at least in theory, no fatigue. The difficult issue is that AIE might eventually be objectively better, or at least more consistently empathetic than a human, because it avoids all those messy human factors. Tiredness, lack of concentration, mood swings that inevitably inhibit our own ability to detect and respond to feelings flawlessly 100% of the time. So if empathy was perhaps our last bastion of perceived unique human superiority, AI perfection in this domain threatens our fundamental sense of identity.
So how do we even begin to establish a functional moral framework for this, especially when the definitions of the core concepts empathy, emotion are so fragmented, and the AI might, in some metrics, perform better than us?
Well, given that a universal, generalized gold standard for ethical AIE seems structurally impossible because of that very fragmentation of definitions, the sources suggest pivoting towards an ethics of care approach. This could be a critical shift. You see, traditional ethics often focuses on ethics in the large, formulating general rules that apply to everyone. The ethics of care, in contrast, emphasizes the specific context, the relationships, the individual circumstances. It's ethics in the small.
And AIE might actually enable this more personalized ethical response.
Potentially, yes. Emotion recognition software could enable applications to assess and respond to specific, individual, context-dependent needs, rather than relying on a rigid, generalized rule set. So in the current state of things, the sources suggest AI technologies function best when viewed as ethical machines in a relational sense. They are embedding and responding to the interests and values of the entire human-machine system. It's more like human augmentation right now, rather than creating isolated, independent moral agents.
That really underscores the need for an interdisciplinary focus then. It absolutely cannot just be engineers and computer scientists building this stuff in isolation.
It absolutely cannot. The sources consistently stress the crucial role of the digital humanities, sociology, psychology, philosophy, social sciences. All these disciplines must inform the initial design, the ongoing evaluation, and provide sharp critique of effective AI systems. We have to center human values, psychological stability, cultural nuances, and lived experiences in the technology development process from the very beginning, not just try to bolt them on as an ethical afterthought.
Wow. This has been a really deep and definitely thought-provoking exploration into the state of machine empathy. The central tension we've uncovered seems crystal clear. AIE holds perhaps the key to achieving truly ethical, human-aligned AI in the future, but only by forcing humanity to confront, define, and maybe value its own, often messy and imperfect, emotional uniqueness more deeply. The entire journey feels like a kind of collective self-reflection prompted by the machine.
That's a great way to put it. The machine is forcing us to pay much closer attention to what we actually are. And if AIE ultimately forces us to rigorously recognize and value our own complex emotional abilities more fully, that is perhaps the most profoundly human outcome of all this technological development.
So here's a final provocative thought for you, our listener, to mull over as you inevitably encounter more AIE in your own life. If the core goal of AI development leans towards eliminating error and achieving a kind of emotional perfection, a goal that increasingly challenges the value we place on our own fallible, complex human emotional landscape, does the future of humanity lie in seeking our own technological augmentation? That is, embracing transhumanism to try and stay more human or better than the simulation? Or should we perhaps lean the other way? Fully embrace our necessary human imperfections and focus intensely on cultivating those unique, evolving emotional abilities and connections that AIE is currently trying so hard, yet perhaps always imperfectly, to replicate.
That's a profound question for this emerging feeling economy, which is really only just beginning. Thank you for joining us on the Deep Dive.
Until next time.